Okay, we just finished modeling our ground beam and ground floor slab. So let us go to the first floor slab and beam. Okay, so for this one, this is quite challenging. Okay, because we have to assign the SFRS for the beams. Okay, let's say for this beam, for the first beam, I want it to be 250 times 600, and I want it to be in a seismic force resisting system, and this is in direction 1 and it's in intermediate. Okay, you can do the beam first and then you can assign it later. Okay, kalau you tak cakap, you boleh buat beam je dulu, buat semua beam and then you click, you assign, you click, you assign. Okay. Okay, tapi kat sini saya nak tunjuk, okay, saya nak buat satu. Saya nak buat semua sekali adalah saya nak buat terus sebab saya nak gunakan copy and paste punya ni tadi function. Okay. Okay, so this one and then click here, edit, copy. Okay. Okay. So kita boleh check, kita pergi ke review view and then this one. Okay, kita check balik betul tak kita buat tu arah direction 1. Okay. Okay, so the color is here. Okay, means this is direction 1 for IMF, intermediate moment frame direction 1. Okay, so this is the color for the wall. Okay, sudah tukar jadi color pink but still in direction 1. So it's okay. Next, we can proceed with the other beams. Okay, model, beams. Okay. If the beam is fully connect from column to column, mean is in SFRS. Okay. Direction 1 and then the type is intermediate. Okay. Oh, sorry. Okay. So you just copy. Okay, and then okay, mirrorkan. Okay, and then untuk beam yang menegak, okay, menegak ni dia masuk dia dah direction lain. Okay, dia dah direction 2. So we go to the beam. Okay, saya nak dia besar sikit. 260. Okay, dia sudah direction 2 and that is intermediate. Okay, so it's from here sebab dia ada cantilever. Okay, from here to here and then okay sampai sini and then you click enter. Okay, okay, dia nampak situ tapi sebab dia cantilever saya tak nak dia besar sangat. So kat sini you can adjust span, first span and then last span you can resize. Okay, span number 1, let's say you can resize the span. Let's say go to edit 250 times 300 only. Okay, okay, nampak tak dia punya span sini dah kecil sikit. Okay, also the span number 5. Okay, you select this 250 times 300. Okay, so dia dah semakin kecil. Okay, then barulah you boleh go to edit and then you copy. Okay, kalau dia similar you boleh copy. Okay, seterusnya you buat lagi new model beam. Okay, okay, select the right size. Make sure you select the right size. Maybe we can use smaller size. Okay, in seismic force resisting system, direction number 2, intermediate, and then select here. Click enter, and then okay, you can select span number 1. Ni boleh kecilkan dia, make it smaller. Okay, you can check. Okay, it's okay now. So you can copy, edit and copy. Okay, and then you can do the mirror function. Use the mirror function. Oh, sorry. Okay. Okay. And then the rest will be, okay, tengok satu lagi. Here, kita tertinggal. Okay, 250 kali 500. Direction number 2. Still intermediate moment frame. Because all is DCM. Okay. Click here and also here. Okay. Dekat ground tadi sama tak? Okay, dekat ground ada beam. Okay. So this one. Okay, dah complete. And dekat hujung ni ada satu beam kecil. Okay, kita buat but this is not this is not in SFRS sebab dia dah jadi secondary beam. So saya pilih size dia adalah saya edit I want 175 kali 300 and saya tak nak dia in. Okay, saya tak perlu klik di sini sebab dia adalah secondary beam. So klik macam ni saja. Okay. Okay, and this one, and then you copy. Okay. Okay. And then yang tertinggal lagi macam kat bawah ni, this one. Okay. Okay, kat grid line 4 and grid line 7. Okay. But this is also secondary beam. So we don't need to assign as SFRS. Okay. Want a bigger size. Okay. Here. Macam tadi juga dia quite challenging. You click function and F2. Six meter, okay. Click function and F2. Okay, bawa sini. Okay, enter. And then you go and copy. Copy, select the right base point, and then you can do it easier. Okay, then we can check. Okay, go to the review view, review, and then show auto state. Okay, okay. Can you see the color now? Okay. Okay, this one. Okay, kat tengah-tengah ni, this is secondary beam. So secondary beam is not in SFRS. So this beam is which direction? Okay, this beam is in direction 1, intermediate moment frame direction 1. Okay, this is intermediate moment frame direction 2. Okay, this is very important. When you dealing with seismic design, this is very, very important. Okay, and then we can go assign our slab. Saya rasa slab. Okay, so we can assign the slab. Yeah, similar approach with the ground floor. Go to new slab. Okay, two-way slab, 150, and then select. Okay. I believe you know how to determine between one-way and two-way slab. Okay. And then new slab. Okay, 90 degrees. And it's one-way slab. Okay, you see the direction is okay now. Okay. Okay, actually here is area for staircase. Okay, area of for staircase. So you must do opening. Okay, you must do opening. How to do it is go to the slab. Uh, sorry, column drop. Okay, slab opening here. Slab opening, and then you do the opening. Okay, kalau you tak buat opening, something wrong will result for your beams later. Okay, so you do the you assign the slab and then you do the opening. Okay, go to slab opening and then here corner is okay. Jangan sampai kena beam atau kena column. That nearest lah, nearest. And then another one is here. This is the slab opening because this area is for staircase. Okay, so this opening, and then we just copy the opening one. Sorry, this opening. Okay, sorry, I just select the opening. Okay, select opening, and then I copy pun boleh, mirrorkan pun boleh. Okay, so I mirrorkan lah, dia lebih accurate. Okay, so mirrorkan. Okay, so means this ada opening. Okay, select ada opening. Okay, dah siap semua, so you can go to your structure. Okay, nampak tak? Bila you buat tadi, you pilih yang unique tadi. You buat dekat floor number 1. Okay, floor number 1. And then the rest will follow the similar. Faham tak? So sebab tadi kita buat this one. This is okay, unique means dia only dia saja. But number second, third, fourth and roof will follow the properties of number 2. Number 2 means this one. Means the first. Okay, so apa pun yang you buat, dia akan follow. So kerja you jadi mudah. Okay. Okay, so this one dah siap. Okay, click and then you kalau sesekali you go to model and then you click validate. You click validate, nak check model you tu ada yang okay ataupun ada yang tak kena. So you click validate. Okay, so validation model dia dapat tick warna hijau means everything is okay. So the structural integrity is okay. Okay, so you go to the this one structure, go to the top level. Then okay, so you just has to complete all the beams here. Okay, beam. I want to make it okay, let's say this one. But it's still in seismic force resisting systems. Direction 1, intermediate. So direction 1 is yang melintang ni. Okay. Okay, and then you boleh copy kalau nak mudah, you copy. Okay, because they're similar span. And then go to model again, beam. This time is okay, make sure you select the section yang betul. And then seismic force, select the direction 2. Okay, this is quite complicated, so that's why you have to be careful. Okay, and then you edit, copy, Okay. Okay, another beam is here. Alright. Direction 2. Intermediate moment frame. Okay, we can copy. Okay, and then go to slab. Okay, everything is two-way slab. Go, this is also have slab. Okay, as roof. Let's say your building is flat roof, then it's okay. Okay, so okay, this is your structure. Okay, and then go to model and click validate to check. Okay, so your model is valid. So this is your structure. Okay, let's say this is the proposal number 1. Okay, so for proposal number 2, if you want to include the wall here, let's say your wall is here, so you have to delete this beam, and then you just have to delete this column and then replace by wall. Okay. Okay. So you just have to replace the beam with wall. Okay. Any question? Okay, let's say you have a water tank here. So maybe you just use a thicker slab and so on. Okay, you should have beam actually here. Okay, we name it as okay, let's say go to the top roof. Okay, let's say you have water tank here. This is your motor room. Okay, and this is your water tank. Let's say here and here. Okay. Okay. Okay, let's say so I'll go to the beam, and the beam is quite deep, 250 times 300, but the alignment top is 300. Okay, let's say the beam is times 700. Okay. Okay, alignment is top. Okay, let's say for every 1 meter, you want to do it every 1 meter. So this is 6 meter, right? So let's say it's 1 meter. So every 1 meter, okay, this one, go to this one. Okay. Okay, can you see the beam? The beam is, nampak tak? Dia dekat atas sikit sebab saya buat tadi. Okay, the alignment here is, okay, go to alignment here. Major offset is 300 from the top. So this is the top, so 300 is offset. So because we want, this is our plane. Okay, we want to put our steel water tank later on here. Okay. So we can copy and paste. Okay, you just use copy and paste. Okay, here, edit, copy, base is here, paste. So you don't have, okay, for this case, you don't have to, you don't have to provide the grid line from early. Okay, you just have to select the point properly, and then you can, once you get the 1 point for every 1 meter, let's say, and then you can do it easily. Okay, and then mirror. Okay, so let's say we have 2 water tanks. Okay, and here, so we have simply supported, one-way slab. Okay, new slab. Okay, 90 degrees and this is a one-way slab. So here, here, and here. Okay, so here and here. Okay, and then you save your work. Okay, so this is your model. Okay, this is the area for water tank. Let's say this is for other machinery like aircon and other M&E equipment here. Then we put it here. Okay. Okay, so next is assign the load. I believe you know how to assign the load. So I just give you the value randomly because we are running out of time before I can show you on how to do how to run the seismic design. Okay. 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 Save your document always. Go to the ground and then choose here at the bottom. Choose the dead load, and for the ground, okay, the dead load on slab is here. Load. Okay, area load, select area load, and then it's equal to 1. Okay, it comprises of the finishing, the M&E, and so on. Okay, so okay, everything. Sorry, I want to do the UDL first. Okay, UDL is dead load. Okay, you must calculate properly. Okay, let's say from here, the UDL, your clear length, 500, 600. Okay, so let's say, so our beam is, what is the smallest? 500, right? The depth tadi 200 times 500 kan? 200 times 500. So this is 3000. So 3000 minus 500 means 2500 equal to 2.5 meter. So the brick wall, okay, the brick wall is equal to 3.0 kilonewton per meter height per meteran. So we multiply by 2.5. What is the answer? 7.5, right? Kilonewton per meter. Okay, so this is the loading. Okay, you can calculate yourself. Okay, I just give you an example. The simplest way. Okay, it's 7.5. So just, okay, let's say here. Okay. Okay. For your level, okay, for your level, you can, oh, sorry. Okay, so it complete. Okay, check everything. Okay, then you can we can assign for the area load is 1, dead load. Okay, just go to the for every apply for every floor. Okay, okay. So this is the how to do the loading. Okay, for the dead load, and then this is for the imposed load. So you have checked the code. Okay, what is the value of imposed load? is area, and then let's say 2.0 for room. Okay, this is for residential area. Let's say this is hostel building. Okay, and then for corridor and staircase is 4. Let's say this is there's a storeroom. Okay, a storeroom also 4, maybe 3. 3 or 2. Okay, 2. Let's say 2 because this is just under the staircase. Okay, so the load is not too heavy there. Okay, and then go to the first. Oh, sorry, this is first. Oh, okay, this is the mistake. Okay, this is the mistake. Okay, means apa? We cannot do source for roof. For roof, it should be unique. Okay, it should be unique for roof. Kalau tidak nanti you buat loading dekat roof, semua loading sama dekat floor lain. So dekat roof, it should be unique. Okay, it must be unique in roof. Okay. Okay, so you boleh buang lah roof dekat ni, yang lain-lain ni. Okay, dekat roof dia kena unique. So you can redo again for this one. I'm so sorry. Okay, so you can select every beam here. Okay, delete and also delete all the slab because this is first floor. Okay, and then you just go to the slab, new slab. Yeah, sign. Okay, let's take a look. Okay, this is dah okay sekarang. Then go to model, try to validate. Okay, it's okay. Okay, means okay. Please take care, class. For roof level, it must be unique. Okay, it cannot follow the other floor because the loading here is also not similar to the other floor. Okay, so let's this okay. Baik. Okay, I stop the recording. Okay, let's say still have time. So we go to the load. Okay, let's say the load is similar macam tadi juga. Full UDL 7.5. If you know the fastest way to assign, please let me know. Okay? Because I don't know. If you explore fastest way to assign load, okay, please share with me. Okay, this is from staircase. Okay, so for this one, for the parapet wall, okay, the value is maybe 3.6. Okay, lower value. Okay, because we have okay, shorter distance is 3.6 only because the brick wall there is just up to your chest level. Okay, and so we have wall from unit to unit. Okay, Okay. Okay, so this is the dead load, and the floor, the area load is equal to 1.5. Okay, because we have to cover for shielding. Is here also? Okay, fastest. Okay, faster 1.5. Okay, this is no load here. This is also no load. Okay, and then for impulse load, just like the ground. Okay, 2. Let's say here. Actually, for the staircase, you have to determine from the staircase and then assign it as load on beam. Okay, and then another one is 4. Okay, you have to assign. Okay, you have to determine. You have to calculate what is the value from impulse load and dead load from the staircase, which will rest on this beam. Okay, you have to calculate later. Okay, and then okay, so it automatically up to the upper floor level. Okay, and then at the roof level, so you have let's say dead load. Okay, from this UBL, maybe you have to calculate. Okay, you have to calculate what is the value from your water tank. Okay, I just give you example. Okay, and then the rest should be the parapet wall, 3.6. Okay. Okay, so this is okay, and then for the use area load, okay, it's back to 1. Okay, okay, just make it here. Okay, faster. Okay, can understand faster. Okay. Okay, we have finished assigning the load, the both for both dead load and imposed load to all the floor. Okay, let's say here you can see the imposed load on the top floor is 0.5 only. Okay, and also for the roof, also for imposed load also 0.5 for maintenance purpose, and the dead load on slab is 1.0. Okay, if you complete all these tasks, so you can proceed to the design part. Okay, but before that, make sure you check everything. You can check the assign SFRS later. Okay, should be like this one. Okay, okay, the plate also not in SFRS. Okay, then okay, before you do the design, make sure for the load. Okay, you must click the decompose. Okay, you must click decompose because you want to transfer the load from slab to the beam. Okay, okay. This is the load. The load is rest on the slab, but we want to decompose so it can be transferred to the beam. So you just click decompose. Okay, you can see here, this line exists now. Okay, before we click decompose, this line is not exist, but this line will appear if we click decompose, and this line is here because this is for one-way slab. It will be go to the longest beam. Okay, so this is right. So click save, and then can go to the seismic load. Okay, seismic vessel. I will give you the case later. Okay, for group 1, group 2, up to group 5, what is your case? And then every group will have one value of PGA, alpha GR, and two salt type. Okay, alpha GR, let's say alpha GR is, okay, let's say here, you go to the Sabah, okay, Sabah, and then the alpha GR is 16, let's say 16, or let's say I give you 10% of G, and then on the salt type D, let's say, okay, I give you alpha GR, let's say 10% of G, and two salt type, let's say D and C. Okay, so you have to run for both salt type. Okay, and then number of story is 7, and then ignore at the ground. Okay, ignore at the ground, and this will be calculated automatically. Okay, so we ignore the ground, ignore seismic force in ground floor and below, and we do it for the activity class medium for DCM. Okay, our importance class is 3 for residential. Betul tak? Residential is 3. And then we go next. Okay, let's say this one. I will give you later the condition, the salt type, the state, the region, and then the alpha GR I will give you later. And then next, we click here. The procedure to be used is the model response spectrum analysis. This one, model response spectrum. This will take longer time to analyze. Okay, hope your computer is okay. And then this is all other structural system. Okay, because we have a leaf core. Okay, next. Structural type is concrete frame. And frame system, dual system. This dual system is still 1.3. So 1.3. Behavior factor is 3.9. Okay. Next. Okay, so you go everything. Okay, it's the dead load. Okay, the factor will be calculated automatically according to the code. And next, and then the finish. Okay, next, finish. And go to the load combinations. Go to the load combinations and you check all this one. And you have to generate. Okay, also you have to generate for gravity load. Okay, sorry, gravity load. Next. Finish. Okay, must have gravity load. This one. Okay, so it's okay. You don't have to panic. Go to the wizard again, and then okay. Next, finish. Next, finish, and then you check the combination. Okay, all these must appear. Okay, base shear, gravity, and then the seismic RSA. Okay, all these must appear, and then you click OK. Okay, and then you save your project, and then for your design setting, you go to setting, and then for your beam, okay, it appear here. Okay, concrete. Okay, cast in place for your beam. Reinforcement setting, longitudinal bar we use 12 to 25. The rest will be the same. And then link setting we use 6. The minimum and maximum we use 8. And then the maximum spacing is limited to 2 to 5 only. Okay, 2 to 5 only. And for column, Okay, we use 12 to 32, and then link we use 6 and 8 only. Okay, maximum center spacing is limited to 175 only. Okay, this is for the DCM. Okay, limited to 175. Minimum reinforcement ratio is equal to 0.1. Okay, in Tekla we have to reset this set. Okay, this setting. Okay, according to the code. Okay, this one. It's a wall. Okay, reinforcement layout. Okay, vertical bar. Let's say 16, 12. Make it 16. Maximum bar size. You can make it 25. In end zone also 16 to 32. Okay, make it 0.1. End zone, horizontal bar. Link or confinement, we make it 12. Okay, end zone also 12. Horizontal bar also 12. Okay, so use this setting. Maximum link horizontal bar, we make it 300 only. Okay, and then you click OK. Go to your, save your project. Go to your model, then you validate the model, and then you go to design, and then you validate. This is important because the first one is you must run the design concrete static. Okay, this is the step. Okay, after you set up everything, you go to model, you validate, go to model, and then you validate. Okay, and then you go to the design, and then you click validate, and then you go to the design concrete static. This is the first step. Okay, design concrete static, and then you run the analysis. Okay, you can go to show process. Okay, to check. Okay, how long okay the process will take. Okay, if you use the design concrete static, usually for this model maybe around 3 to 4 minutes, if I'm not mistaken. It depends on your model. Okay, the more complicated your model, okay, the more time it will take. Okay, so this this element already fail. Okay, these elements already fail, so you have to, okay, the fail element is column and some beams here. Okay, so you have to enlarge your beam and enlarge your column. Okay, it only take 33 seconds. Okay, good, only 33 seconds. Okay, so the process is you have to enlarge your column, okay, and your beam, and then after that, okay, for this part, okay, I will consult you later. Okay, what will happen to this part? Okay, why the color is okay, what you have to do if the color is yellow here? Okay, okay, I will consult you later. If your model is fail, so you have to resize your elements, and then after that you go to analyze, and then go to model analysis. But make sure make sure you, okay, I just want to save your time. Okay, if the element is failed, so you have to resize, and then you have to redo again. You have to design again, and then do the design concrete static again until all the element is passed. Okay, until all the element is passed, and then you go to element, and then you do the model, first order model, and then you go to the design, you validate, and then you go to the design concrete RSA. Okay, design concrete RSA. This will take long time. Okay, maybe up to 30 minutes and up to hours, depend on your complexity of your model. If your model is so complicated, so it will take longer time. Okay, design concrete RSA. Okay, you click this one. Okay, design concrete RSA. Okay, I show you if the design concrete RSA is finished. Okay, let's say for this model, show process. For this model, it took about to do the RSA. Sorry, if I'm not mistaken, this model took about 20 minutes to finish the RSA. Okay, and then after the finish, you can go to report. Go to report and go to the seismic design. Show the reports, and then you can double click here and here, single click here and here, and then this is the report. Okay, this is the case of your building. Okay, this is the percentage of G, the soil type, the region is in Sabah, and this is the mass of your building, and this one is the fundamental period of a building for direction 1 and direction 2 is differ, and this is the SDT1 value of your building. Okay, and this is the model base shear force for your building. Okay, for direction 1 and direction 2. Okay, and then you can go to the report again, go to material listings, and then show reports. Okay, and then you can go to the lower part, and then you can check the reinforcement, the amount of reinforcement inside your beam, columns, and walls. Okay, this is going to be your report, as well as this one. Okay, this one is also must be included in your report, and also this one. Okay, we can go and we want to do the comparison between the seismic design and the non-seismic design, and then we can compare the cost. It's okay, I will brief you later about that one. Okay, I will brief you later about that one, so you don't have to worry. But the important thing is you must make sure that this element is passed for the design concrete static before you can proceed to the design concrete RSA. Okay, so thank you very much for your time. I hope you can do your project well. Thank you very much.